Hope it's recording. Okay, so go back. Goes over there. Okay. Now we start with the first chapter. The second chapter of physical chemistry. So name of the chapter is structure of atom or atomic structure. Okay. The chapter is really important because the fundas that we have in structure of atoms, we're going to learn new atomic model. We're going to learn new ways of writing electronic configuration. And this new pattern of writing electronic configuration is very important, especially from organic, inorganic. मतलब आप कोई भी चैप्टर लो, इन मेजॉरिटी चैप्टर्स एटॉमिक स्ट्रक्चर का फंडामेंटल आता है. चैप्टर थोड़ा सा लेंदी है. Initial part of the chapter is a basic revision of whatever we have done till 10th standard. So there are some parts which you people already know. For example, if someone can tell me what are the basic constituents of an atom? Atom is made up of protons, neutrons, and electrons. Excuse me, what's the charge on a proton?
+1.
Positive charge. Electron?
-1.
And neutron?
Neutral.
Neutral. What is there in the center of the atom? Nucleus. Charge on the nucleus?
Positive.
Why positive charge on the nucleus?
Consists of protons and neutrons.
Because inside the nucleus we have protons and neutrons. And where are the electrons?
The
Revolving around the nucleus in different shells, subshell, orbits. Probably you use the word orbit. This is the atomic model, okay, which was given by Rutherford and Niels Bohr. We'll study about atomic models. However, as we move through the chapter and we reach the last part of the chapter, we study a new atomic model, जिसको हम बोलते हैं quantum mechanical model of the atom. And that new atomic model is थोड़ा सा different till what we have learned till 10th standard. But initially, we have to first understand how did these subatomic particles were discovered. थोड़ा basic physical properties of these subatomic particles. Okay. Now the first theory or atomic theory is something that we did in mole concept. It was Dalton's atomic theory. Anyone remembers some key points of Dalton's atomic theory? क्या था Dalton का atomic theory?
atoms are smallest indivisible particles.
Smallest indivisible particle. ठीक है. Can you further divide the atom according to Dalton? No. Then atoms of same element had
Similar
physical chemical properties, different, had different. But then was this a limitation? Later on, was Dalton's theory, there were some problems with Dalton's theory. I think हमने लिखा था. What were the issues or what were the problems when isotopes were discovered? Very nice. किसी को याद ही नहीं है.
The isotopes were not following that property.
Isotopes did not follow what Dalton said. Can someone give me some more drawbacks of Dalton's atomic theory?
Atoms were divisible in 3 parts: protons, neutrons, and electrons.
Eventually we came to know about that. Okay, so initial part of the chapter we have to first start by understanding the discovery of these subatomic particles. So we'll start with the first experiment. Probably ये थोड़ा बहुत basic हमने I think 9th standard या 10th standard में भी किया होगा. So the first particle is the discovery of electrons. The first particle that we will discover is the discovery of Now for this discovery we have something called as the cathode ray tube experiment. We call it cathode ray tube experiment or the discharge tube experiment. Chalo. Now, what is this experiment? Or let's first understand the experimental setup of the discharge tube experiment. Now, we start with a discharge tube. Now, what exactly is a discharge tube? Though this is very old tech, but a discharge tube, people, is similar to, have you ever seen that old fat television? आजकल तो होते नहीं है, but initially there used to be these fat televisions या computers monitor. आजकल monitor भी, these are all LED or या flat screen monitors, but we used to have these old televisions जिसका ये side view would look something like this. और यहाँ से वो केबल जाता था and connect करते थे हम. I don't know if you people have ever seen fat old television. तो अगर उसका बाहर का plastic covering हम हटा दे, inside what we have is somewhat similar to a discharge tube, and there's an electrode over here, and this is your television screen, and you can say electrons produce that picture that we see. So a discharge tube is somewhat similar to like this. ठीक है? Now हमारे पास दो electrodes हैं. ठीक है? So I have an electrode over here. यहाँ पे मेरे पास एक electrode है. Now this electrode is connected to a very high voltage source. I repeat, the electrode is connected to a very high voltage source. Chalo. Now if you see this part of the electrode connected to the negative terminal of the battery, here this electrode is called as cathode. Cathode कहाँ पे connect किया people? The negative terminal of the battery. On the other end we have the anode connected to the positive terminal of the battery. Now if you look at the anode ka electrode, it has tiny gaps in it, tiny holes, which is called as perforated anode. ठीक है? I'll later tell you कि वो tiny gap क्यों है. Now this is very important people. Very high voltage is applied over here. Now the reason it's very high voltage is we're going to have gas inside the chamber, and basically हमें gas को ionize करना है. Can anyone tell me what do you mean by ionization of gas?
Splitting the molecules into atoms, ions.
Okay. When you split a molecule, it's more like atomization. And what was ionization? The 10th standard में पढ़ा होगा ionization, energy, ionization, potential, IP कुछ बोलते थे.
Amount of energy got removed.
Anyone? What was IP? What was ionization, energy, ionization, potential? Removing an electron from an isolated gaseous atom. ऐसा कुछ किया है? Periodic table 10th standard. ठीक है. Now, so what we have inside the discharge tube is gas which is present at very low pressure. I repeat, इसके अंदर we have gas at very low pressure. ठीक है, and how do you get that very low pressure is this is connected to a vacuum pump. I repeat, the pressure is extremely low. इतना low कि ऐसा समझ लो almost it is near vacuum. ठीक है, so it is connected to a vacuum pump. Gas at very low pressure, very high voltage is applied. Any questions in the experimental setup till here? Now, behind the anode, there was a small coating of zinc sulfide, which is a fluorescent material. What exactly a fluorescent material means? It is somewhat similar to the board. Whenever I apply pressure, like you can see that yellow color, or so if there is a charged particle which collides with the fluorescent material, वहाँ पे एक bright spot will be produced. Getting that? That is what is the meaning of a fluorescent material. So it's coating of zinc sulfide. This is the basic setup. And I repeat, why do we have gas inside the chamber and why such high voltage is applied? एक बार फिर से लिखते हैं. It is because we want to perform ionization. Ionization का मतलब क्या होता है? Let's say inside the gas chamber, if I take hydrogen gas, so I want that hydrogen to become so what are we doing over here? We are removing an electron from an isolated gaseous atom. Or you can take any gas inside the gas chamber. And actually, while doing the experiment, various gases were taken. So we can make assumptions that let's say we have hydrogen or we have oxygen. You can also take, let's say, sodium or vapors of sodium. So sodium is a metal, normal state it's solid, but you can vaporize, you can take vapors of sodium. So this will convert into what, people? Na plus and E minus. With me till here? Okay, so this was the experimental setup. Now what happened? When the experiment was started, what was observed is on the fluorescent material, these spots were observed, which means that there are particles which are going from anode towards the the particles which are going from cathode towards the anode. Now, how did he come to that conclusion that particles are going from cathode towards the anode first? Because obviously the spots observed are behind the perforated anode. Now, this can also help you judge what was the charge on these particles. It is moving towards the positive electrode. So what is the charge on the particles? Negatively charged particles. See, initially there was a confusion कि ये particle है कि ये ray है. Even Thomson was not sure about that. कि whether are these particles or are these rays. So we need experimental data in order to determine that the flow from cathode towards the anode, are these rays or are these particles. Did you people get that? So in order to prove that, there was some experimental setup को थोड़ा सा change किया. I'm not drawing the entire diagram again, but this is the cathode wala part, anode. Now the first thing that was done is, between the cathode and anode, he placed a metal block. So this is that metal block. Between the cathode and anode, एक metal block रखा, and there was a screen placed. And what was observed is a shadow was casted on the screen. It is somewhat similar to this. I know there's light ऊपर से आ रहा है. If I just place my hand, there's a shadow. Why is there a shadow? Obviously because my hand is obstructing the light which is traveling. Getting that? It's exactly the same. So there was a shadow produced. Second experiment which was done is, between the cathode and anode, there was a thin mechanical fan placed. And now when the particles are moving from cathode towards the anode, what will happen, people? The mechanical fan will start to rotate. Are you people getting the experiment? Third, see, these experiments prove that these are not rays, these are particles. But we want to confirm, apart from being particles, that they carry a certain charge. We know that what charge are they carrying? Negative, because they are moving towards which electrode? Positive electrode. But what is the, we want to confirm that it is negative charge. There are two ways to do this. Between the cathode and anode, यहाँ पर भी we can place electric fields. So let's say यहाँ पे हमने field place किया negative और यहाँ पे हमने field place किया positive. So the particles will get deflected towards which of the two electrodes? I mean, it will go, the particles will move up or will the particles move down? Trajectory कैसे change होगा? The particles' trajectory would change like this. Are you getting that? Simultaneously, another way to determine is you place or you apply magnetic field. And there was a deflection also observed in the magnetic field. Where do electrons deflect in magnetic field? ये आप physics में पढ़ोगे in magnetic effect of electric current chapter में. But deflection in electric and magnetic field further confirms that these particles are charged particles. Remember, अभी तक electron है ये नहीं पता, but we know that yes, these are some negatively charged particles. Any questions still here?
Can you explain the second one?
ये वाला experiment, ये वाला, हाँ. See, what's really happening is, let's imagine that this is that mechanical fan, or ऊपर देख लो या mechanical fan. So it's like if the electrons are traveling, they'll collide with the blades of the fan and they start rotating the fan. Had it been an EMR, electromagnetic radiation, then that radiation would have simply traveled through the blades of the fan, or even through the metal block. Isliye even the metal block was an extremely thin metal block. If you put a thick metal block, obviously electrons cannot really penetrate through them. यहाँ तक समझा? Any questions still here? Now, experimental data, ये जो observation ये इस पे you can have statement based questions, especially for NEET. Statement based questions आते हैं इसमें. JEE में, however, there is a very less probability कि they would ask any statement based question. ऐसा नहीं कि पूछेंगे नहीं, पूछ सकते हैं, but probability कम है. NEET के लिए the probability is very high. Now, what Thomson did is, Thomson calculated something called as the charge to mass ratio of electron. Now, to calculate charge to mass ratio, a similar experimental setup was there, but ये experimental setup आपको कोई एग्जाम में नहीं पूछेगा. However, if you want to really understand कि where did this value come from, the charge of the electron to the mass of the electron, how did Thomson calculate the charge to mass ratio? Setup is exactly the same. हमारे पास एक, I'm just drawing a rough diagram with this time. You know, we have a discharge tube. Discharge tube के एक end पे, on the left side क्या था people? There was cathode. What was the charge on the cathode? Negative charge on the cathode. Then what was placed here? What was the type of the anode? Why was it perforated?
To allow electrons to pass through and enter zinc sulfide.
अगर anode में gap नहीं होता, if there would have been no gap in the anode, how will the electrons go through that anode का electrode towards the fluorescent screen? And that is why कोई gap था बीच में. I repeat, anode was something like this. अगर gap नहीं होंगे, then how will the anode particles pass through? There was a gap anode में, hence we have perforated anode. Now, behind the anode, similarly हमने क्या किया था? हमने एक fluorescent material का coated sheet था. This was zinc sulfide coating. Next, what was done is, in the trajectory, in the path of the cathode rays, there was electric field placed. So let's say this is the trajectory. How is the electric field placed? एक ऊपर, there's a rod like this, and there's a rod like this, and the cathode rays are moving like this. But along with electric field, even magnetic field was placed. So थोड़ा placement समझने की कोशिश करो. Can you hold this? अगर ये trajectory है, it is going from this. So how is the electric field placed? It's like this. ऐसे rod ऐसे imagine करो, and there's one here. Then magnetic field was also placed. Magnetic field was placed like this. So they are all perpendicular to each other. I repeat, यहाँ पे electric field है और यहाँ पे magnetic field है. अब 3 diagram है, 2 dimensional board पे बना नहीं सकते, इसलिए I'm just showing the electric field. ठीक है, तो यहाँ पे ऊपर, and let's say you can imagine there's a magnet placed here and a similar magnet placed behind the board. Why are we doing this? Because यहाँ से कौन आने वाला है? What are these rays? Electrons. As soon as it reach, in which direction people they will move? कहाँ पे deflect होके जाएंगे?
Downwards.
They will move downwards. Why will they move downwards?
Positive charge.
For, let's say if there would have been no electric field, तो कहाँ जाते? If this would have not been there, तो कहाँ पे जाएंगे? Where will these cathode rays move?
North of the magnet.
Or even the magnetic field is not there.
Straight.
They're going to go straight. So first क्या किया? When they move straight, we are going to get a dot over here. कुछ भी नंबर दे दो, नेम दे दो उसको. Let's say this is B. Now if I apply very strong positive field, where will they deflect?
Down.
Downwards. यहाँ से आके let's say इसको नाम देते हैं C. And similar magnetic field को थोड़ा change करके I can also deflect them in a different direction. And when there is no deflection, these particles are going to move straight. With me till here? Bolo re. So, depending upon what is the strength of electric field and the strength of magnetic field, we are not shown the magnet, but there is, yes, a magnetic field. You can deflect these particles. And the deflection can also be nullified. Nullified मतलब what Thomson did is एक ऐसा particular value पर, I repeat, we wanted a particular value where the force of electric field was equal to the force of magnetic field. I repeat, when the force of the electric field became equal to the force of the magnetic field. And that particular point helped Thomson to calculate the charge to mass ratio. The value came as 1.67 into 10 to power 11 coulombs per kg. So, majority के लिए आप सिर्फ value by add करके रखो, that is more than enough. So if I ask you what is the charge to mass ratio of electron in cathode ray tube experiment, तो आप क्या बोलोगे value? 1.67 into 10 to power 11 coulomb per kg. Students want to understand कि ये value कहाँ से आया? It is for them. Force of the electric field is equal to the force of the magnetic field. How do you calculate force of the electric field? जैसे कि यहाँ पे people, it is the same, वो एक battery था, electric field is charge times potential. The potential difference of the battery, let's say it was E, and charge on the electron, that is how you decide force of the electric field. Force of magnetic field is strength of the magnetic field, which is given by B. B stands for magnetic field strength into charge into velocity of the electron, velocity of cathode rays. Now, कुछ common दिख रहा है on the left and right? तो ऐसे भी लिख सकते हैं, B into charge on the electron is E. ये charge होता है छोटू E into, you can write velocity of the electron. So do you see charge and charge on both sides? क्या कर सकते हैं उसको? So what do you get here? Potential E is equal to B into velocity of the electron. Now, look at this movement, point C का या point A का movement. point C ka movement is like this. If you keep on increasing the force, can I say the movement will go and eventually it will become a circle. That circle is going to have a certain radius. Whenever, let's say you tie a rope at one end and if you rotate, which force is applied
Centrifugal force.
when you tie, let's say, a stone to a rope and you're rotating it? Centrifugal force, ऐसा कुछ था पहले? I don't know. Till 10th standard, you people have learned something called as a centrifugal force, a force which is moving inwards. Centripetal force, centrifugal force starts moving outwards. Centripetal and centrifugal balance each other. What was the formula for centripetal force? mv square by r. था ये 10th standard में mv square by r. Now this centripetal force is balanced by the magnetic field strength. How much did we get the value as? B into velocity of the electron. Left maybe do you see velocity? Right maybe do you see velocity? So what do we have here? mv by r is equal to b. From here, what do you get the velocity ka formula as? E by b. Substitute v as E by b. Therefore, m by r into E by b is equal to b. Using this, you can find the charge to mass ratio. So this is a derivation which I think you'll also learn in physics. They're not going to ask chemistry में कि कहाँ से derive किया. From an exam perspective, आप ये value by add करके रखो. That should be more than enough. But you should understand कि where did that particular value come from. तो ये एक overview भी लिख के रखना is essential. Did you people get that? So what is the charge to mass ratio for the electron? What is the value? 1.67 into 10 raised to. Now, why is this value important? Because even if you change the gas, पहले हमने कौन सा gas लिया था people? Hydrogen gas. The value is 1.67 into 10 raised to 11. You change the gas to oxygen, the value still remains 1.67 into 10 raised to 11. You change the value to sodium, the value remains the same. Hence, I'll make you write all this, but irrespective of the gas taken inside the discharge tube, I repeat, irrespective of the gas inside the discharge tube, the charge to mass ratio for cathode rays will remain the same. Assertion or statement में पूछते हैं. Did you people get that? चलो, so on a new page. जल्दी. You'll first copy this, then I'll give you उसके पीछे का theory.
So how is it called cathode ray?
Okay, so why? पहले एक question है, why is it called as cathode rays? Initially, when the experiment was done, they were not sure whether these are particles or these are actual rays. But since they originate from cathode, they had no idea, and they were not visible. इसलिए पहले नाम दिया था उनको cathode rays. Please write down observations. So we're just writing people key points. Okay, we're not going to write pura sentences. Observation. First, cathode rays start from cathode and move towards the anode. Full stop. Continue. They are not visible. But are observed with the help of fluorescent or phosphorescent materials. Fluorescent, FLUORESCENT. I repeat, FLUORESCENT, or phosphorescent, PHOSPHORESCENT. I'll repeat, pardon me, PHOSPHORESCENT, phosphorescent material. Next point. In the absence of electric or magnetic field, in the absence of electric or magnetic field, they travel in straight line. They travel in straight line. But deflect in the presence of electric and magnetic field. But deflect in the presence of electric and magnetic field. Next point, very important, preferably a red pen अगर है तो. The characteristics of cathode rays, the characteristics of cathode rays are independent of, the characteristics of cathode rays are independent of the gas present, the nature of the gas present, the nature of the gas present in the discharge tube, the nature of the gas present in the discharge tube, and the material of the electrode. And hence we can conclude that, electrons are basic constituent of atoms. Electrons are basic constituent of atoms. Okay. Next point. So we are also clubbing the charge to mass ratio वाला points. ठीक है, एक ही साथ करते हैं, then diagram बना देना. अच्छा, these negatively charged particles were called as electrons. एक point वो भी लिख के रख दो. We know that, but these negatively charged particles were called electrons. Next point. The magnitude of the negative charge on the particle, the magnitude of the negative charge on the particle decides the amount of deviation, decides the amount of deflection, ऐसे लिखता हूँ, decides the amount of deflection. Greater the magnitude, greater the magnitude of charge, greater the magnitude of charge, greater is the interaction with electric and magnetic field, and greater is the deflection, and greater is the deflection. जी हाँ, मैंने खुद का कुछ तो बना के बोल दिया था स्टार्टिंग, वो पॉइंट पूरा या हाँ, greater the magnitude of charge, greater is the interaction with electric and magnetic field, and greater is the deflection. Next point. By carrying out accurate measurements, Thomson was able to calculate the charge to mass ratio, which is I want you to copy this, people. Charge to mass ratio of electron. लिखा? Add एक और पॉइंट इसके बाद. नहीं. Next point. Using Millikan's, Millikan, apostrophe S. Using Millikan's oil drop experiment, the charge on the electron was determined. Please copy the charge, people. So again, a very important value which you need to memorize. How much people is the charge on the electron? Negative 1.6022, or you can just remember negative 1.6 into 10 raised to minus 19 coulombs. I don't know 10th में ये charge पढ़ा है क्या? And this is called as unit negative charge. ठीक है? If you want to know more about how the oil drop experiment was done, there's an atomizer. इतना in detail जाने की जरूरत नहीं है. We just need to know the value. But still, if you want to know in detail, meet me break में. और कभी भी बाद में I'll explain you how the experiment was done. Now, we have charge to mass ratio. How much was charge to mass ratio? Anyone remembers the value? 1.67 into 10 raised to 11 coulomb per kg. That was the charge to mass ratio. We have the charge on electron. So charge मिल गया, charge to mass मिल गया, तो क्या निकाल सकते हैं people अभी? Mass of the electron. When the mass was calculated, so mass of one electron is, anyone remembers mole concept में एक sum किया था in which we had written the mass of the electron.
9.1 into 10 to the minus 13.
Excellent. 9.1 into 10 raised to minus 31 kg. समझा कि नहीं समझा? और ऐसे भी ना वीडियो रिकॉर्ड होते कुछ भी पूछता हूँ तो आई हैव टू से एक्सीलेंट लगना चाहिए स्टूडेंट्स आर आंसरिंग. चलो आई रिपीट, हाउ मच इज द मास ऑफ इलेक्ट्रॉन पीपल? 9.1 into 10 raised to minus 31 kg. So grams में भी हम इसको लिख सकते हैं, but usually kg यूज होता है. How do I convert this into grams? 1 kg is how much in grams? 1000 grams make a kg, बराबर. तो ये कितना हो जाएगा people? 9.1 into 10 raised to minus 28 grams. Very rarely will we use grams, but फिर भी value लिख के रखना है. ये सब parameters of the electrons you have to memorize. We need these for numericals. समझाइए? And I repeat, try to understand this वापस से. This is going to remain, charge to mass ratio is going to remain irrespective of the gas. Because क्या हो रहा है? आप एक आयनाइज कर रहे हो तो सब सेम है. So this remains constant. इसलिए irrespective of whatever you take, charge to mass ratio remains common. But now when we discover protons, this changes. तो वहाँ पे हमें ध्यान देना होगा. Did you get that? Copy the value for mass of the electron. अभी pause कर लेना. I mean, now people, this experiment was really important because see, till electrons were discovered, it was thought that the lightest known element was the atom, and there is nothing which is lighter than atom. Okay, but when using Millikan's oil drop experiment, when the mass of the electron was determined, what was observed is the particle which got discovered, which is the electron, जब इसका mass compare किया with the lightest known element. If we go back to, let's say, somewhere around 1860s, 1870s, 1850s, which was the lightest? It was hydrogen. So what we have here is 1 upon 1836 times the mass of hydrogen atom. बाद में जब प्रोटॉन का डिस्कवरी करेंगे हमको पता चलेगा this is 1836 times lighter than a proton. So what was discovered was something 2000 times almost lighter than the lightest known element. It was a really big discovery back then. तो ये दो पॉइंट्स भी ऐड कर देना. Right. 10 seconds, 15 seconds. Then we will. Now, people over here, if let's say we take the same setup, can someone tell you, because of the high voltage, what is happening to the gas inside the discharge tube? The gas is getting ionized. What do you mean by getting ionized? Let's say if I have hydrogen gas, what is happening to that hydrogen gas atom?
Electrons are separated.
You're removing that electron. If I remove an electron from hydrogen atom, what is left in the hydrogen atom?
Proton.
It's a nucleus. And what is present inside the nucleus of hydrogen atom? One proton. Is there a neutron inside the hydrogen atom? No. So, try to visualize inside the discharge tube. Inside the discharge tube, hydrogen gas was converted into this. Yes or no? And where did the electron move? It went towards which electrode? Towards the anode, because electron पे कौन सा charge था? Cathode पे कौन सा charge? Sorry, anode पे positive. If this went towards the anode, what do you think happened with the H plus? It has to go towards, and that is what Goldstein did. Goldstein ने क्या समझा? That let's place or let's coat the cathode. I'm sorry, behind the cathode, कौन सा material? Fluorescent material of ZNS. And cathode को भी क्या कर दिया? I'm sorry? Perforated cathode. Why did he do that? Because the moment you'll ionize hydrogen gas, it will become H plus. And मैंने क्या बोला people? H plus को हम क्या बोलते हैं? Proton. Anyone who doesn't understand this, why do you call H plus proton? ऐसा करो नहीं समझो तो. Anyone? Why do you call H plus proton? Imagine hydrogen atom. Center में क्या है people? What is revolving around the atom? Electron. What is present inside the nucleus of hydrogen atom? Only one proton. ये hydrogen atom है. Ionization. What is happening because of ionization? क्या हो रहा है ionization की वजह से? You are getting rid of the. निकाल दिया ना? So what is left? Just the nucleus. And what is present inside the nucleus? इसलिए H plus को सिर्फ क्या बोल सकते हैं हम? You will get that? We'll be using this very frequently. We will not really say H plus. हम बोलेंगे proton. Anyone who don't get that? अब समझा? So how many such protons? Depending upon the number of H atoms which were ionized. And now where did these particles move towards which electrode? Perforated cathode. This is the discovery of, I repeat, this is the discovery of protons. But there is a catch. In electrons, we calculated charge to mass ratio. Was it different for different gases? No. But over here, the charge to mass ratio is different for different gas. Why? Because, I repeat, what are we calculating? Charge to mass. Remember over there, नीचे denominator term में mass में it was yes or no? But what about here in the denominator term? If I take hydrogen gas, नीचे mass किसका आने वाला है? किसका mass आने वाला है? H plus. If I change with oxygen, नीचे कौन आने वाला है? O plus has more protons. And hence charge to mass ratio will change. Then I remove O plus, I put Na plus. Will it again change? I have a question. Out of the three, if I give you H, O and Na, which has the highest charge to mass ratio?
H plus.
Lighter the gas, तो उसका mass उतना ही कम, and denominator is less, which means the ratio will be. So कैसे हम बोलेंगे? Lighter the gas, greater is the charge to mass ratio. Very important. So we cannot give a fixed value over here. Did you will get that? Yes or no? Can someone give me the charge on proton?
Plus 1.
How much people was the charge on electron?
1.6022.
Negative. What was the charge on electron?
Negative 1.
Negative 1.6 into 10 raised to minus. So what is the charge on proton?
Positive 1.6.
Plus 1.6 into 10 raised to minus 19 coulombs. That was called as unit negative charge. This will be called as unit positive charge. Mass of proton. Can someone tell me what was the mass on mass of electron?
9.1 into 10 to the minus 31.
9.1 into 10 raised to minus 31 kgs. Mass of proton 1.672 into 10 raised to minus 27, or 1.672 into 10 raised to minus 24. Oh, sorry. Did you people get that? Bolo re. Please write down discovery of protons. Hi. अच्छा हाँ sorry pause करने के लिए yes. Anode rays or canal rays. CANAL. I'm sorry. Anode rays or canal rays. Goldstein, Goldstein, found that by using a discharge tube containing a perforated cathode, some rays passed through in a direction opposite to cathode rays. Next, characteristics. Very important first point if you have a red pen. These positively charged particles depend on the nature of the gas present in the cathode ray tube. Continue. The charge to mass ratio depends on the gas. Next point. Some of the positively charged particles carry a multiple of fundamental unit of electric charge. Next point. The lightest positive ion obtained was called proton. Okay, people, so this was the discovery of proton. So we have discovered two fundamental particles. Give me that one fundamental particle which is left. The neutron. Now people, why are they called as neutrons? What is the charge that they carry? Okay. So the last fundamental particle is the discovery of neutrons. Now, actually, with the discovery of neutrons, there are two paths. There was a scientist called as Rutherford. Rutherford said that we've discovered a positively charged particle, negatively charged particle. There has to be another particle which is neutral. And James Chadwick, he was doing an experiment. He was bombarding beryllium nuclei with alpha particles. Now, first I want to know, have you people heard about alpha particles before? Right? So James Chadwick, what was doing? He was bombarding alpha particles, different atoms. So he was bombarding with alpha particles. So what are alpha particles? Let's first attention में क्या था कि alpha particle, beta particle and gamma rays. ठीक है, नहीं किया तो फिर से करते हैं. What are alpha particles? Alpha particles are doubly ionized helium atoms. So what do you mean by doubly ionized? Helium. Can someone give me the atomic number of helium?
2.
2. Number of protons कितने मतलब helium में?
2.
2 protons. How many neutrons are there? 2 neutrons. And how many electrons are there? 2 electrons. Getting that, people? So helium 2 protons and mass number is proton plus neutron. इसलिए ऊपर मैंने 4 लिखा है. यहाँ तक with me? Now what do you mean by doubly ionized? If you remove both the electrons from helium, He2 plus, that becomes a doubly ionized helium atom. So that is what an alpha particle is. Doubly ionized helium atom. Anyone who did not get this, what's the meaning of alpha particle? Samjha? Can someone tell me beta particles kya the? If anyone remembers. Excellent. Beta particles were nothing but people, they were electrons. And we have something called as electromagnetic radiation, gamma rays. Was all this in 10th standard under the topic of radioactivity from a radioactive nuclei? अगर आपके पास एक radioactive nuclei है, it releases these 3 particles. I'm so sorry, 2 particles, and one of them is a wave. This is alpha, this is gamma, and this is beta. Deflect इसलिए हो रहा है because we've applied an electric field. ये points याद रखना भी necessary है. So I repeat what Goldstein was doing. Different nuclei लिया था, and he was bombarding them, lithium, beryllium, with helium, with alpha particles. Now what he got was carbon. Atomic number, please. 6. 4 plus 2. And so you got that carbon 12 isotope. Now if you apply law of conservation of mass, so 4 plus 2, 6, 9 plus 4. So where is that one missing particle? It is in the form of neutron. So पहले ये मिल, because this was very difficult to find because it has no charge. So where was that law of conservation of mass missing? It was missing because of neutron. Did you people get that? Bolo re. So what's the charge on neutron? It is neutral. So what will the charge be, people? But what's the mass of neutron? 1.674 into 10 raised to minus 27 kgs. कभी कभार हम क्या बोलेंगे? Almost same as the mass of. This is just during numericals. हम क्या assume कर लेंगे? It is almost equal to the mass of proton, but it's not. This is 1.674 and mass of proton was 1.672. Did you people get that? Jaldi jaldi copy this. समझ सकता हूँ ये वाला ब्लू क्या? अयो क्या बात कर रहा है? कोई बात नहीं,
थोड़ा थोड़ा दिख रहा है।
थोड़ा एडजस्ट कर लेंगे। अच्छा होगा लेकिन बता। चलो प्लीज है ना। James Chadwick, C-H-A-D-W-I-C-K. W-I-C-K. James, C-H-A-D-W-I-C-K, bombarded beryllium with alpha particles. And observed that the radiation emitted had no effect of electric or magnetic field. Had no effect of electric and magnetic field. Had approximately the same mass as that of protons. Approximately the same mass as that of protons. And was highly penetrating. This subatomic particle was named Neutron. Due to neutral nature. Now, these are the different subatomic particles, people. It's not that these are the only subatomic particles. Our syllabus scope is still these. However, there are some more subatomic particles. Some basic, in case आपको कभी पढ़ना होगा, we have something called as a positive electron. This one is positron. Positive electron. Inside the nucleus, we have something called as quarks. Then we have some more particles, meson. Then people जैसे H plus को we call proton. We have something called as D plus, जिसको अपन बोलते हैं neutron. H plus and D plus is something that we will use eventually for organic. ठीक है? Now, as homework, what I want is there are certain atomic terms जो मुझे चाहिए आप घर से लिख के आओगे. दिस इज आई थिंक 10th स्टैंडर्ड का ही, तो आई होप सब करके आएंगे ये. You will define for me what is atomic number. Did you people have atomic number in 10th standard? Then I want what is atomic mass number. Then you people will give me what is what are isotopes. You'll also give me as many examples as possible. Did you people have 10th standard में isotopes? ठीक है. Then give me iso bars. I want इनका भी examples. And last, I don't know if this was there. Isotones were there. Isotones नहीं थे, ठीक है. If in case it was not there, it's okay. मत लिखना. If it was there, तो लिखना. But we'll start from isotones then. However, I will ask these. For example, anyone can remember what were isotopes?
Atoms of the same element having different atomic mass numbers.
Same atomic number, different. What were isobars? Same mass number, different. Isotones were same number of neutrons. ठीक है, कल डिस्कस करेंगे. But isotones are same number of neutrons. So I want all these to be written tomorrow. By tomorrow, at the same time, जो भी theory लिखा है, I want everyone to memorize all the points etc. and come by tomorrow. With me? Thank you so much. If you need any help,